Okay, we are doing what, please? We are doing chapter number 4, approximation of the function at the given point. And we are using the process called interpolation. And in interpolation, we are using the simplest case polynomial interpolation to find the approximation of the function at the given point, with the condition that point must be inside the given interval. Smaller the size of the interval, better the approximation of the answer. We have better the approximation of the given problems we have here now. And as I say, polynomial can be degree 1, degree 2, degree 3. If we have a degree 1, we need 2 points. If we have a degree 2, we need 3 points. Degree 3, we have 4 points, and continue like same manner here. Highest the degree of the polynomial give you the better approximation. But I told you, remember I give you 5, 6 examples before that. And if any problem come in the exam from the Lagrange interpolating polynomial, it must be either degree 1 or degree 2, but the chances is degree 2, that degree 2 need the 3 point. And degree 3, of course, we can use, but it will take more time in the examination point of view. Therefore, we ignore in the case of the Lagrange polynomial. Remember, we did, I think, 6 examples before. Let's take this example number 7. This is very good example from examination point of view. And he say, we construct the table for this one. In place of the function x and f of x, I'm using alpha and m alpha, same thing. You can use whatever the function shape here. I say, construct the table for alpha and m of alpha, where alpha is given 1, 3, 5, 6. We are given 4 points. And the function is given alpha minus ex, integral from 0 to 1 here. So what is your first job? To construct the table, you need to find the value of the m alpha, and which you can easily find out by taking the simple integration. We know what is the integration of constant. Integration of the constant is alpha at the constant time the x. And what is the integration of exponential function? Exponential function integration, exactly ex is exactly the same thing. So we can use this one here, the integration, and you will get, this is a jawab of integration. Calculate the jawab at the given upper and lower limit, and that is the formula for your m alpha. So now everything is with us. Alpha already given by the teacher, 1, 3, 5, 6. M alpha, you have to find out by yourself, which you got here now. And now you can find, easily create the table for the given point 1, 3, 5, 6. And then you put first 1. When you put alpha is 1, so you can get M1. What is M1? 1 minus E plus 1, so 2 minus E. 2 minus E, when you use calculator, inshallah, you will get this. And at 3, you can put 3 minus E plus 1 is 4 minus E, which you will get, inshallah, this one. And the same way like this one. So this is your first part finished here now. What was the first part? He said, construct the table for this point. And that's, we construct the table. Now, the second part, he said, use this table to find the best approximation of m at 4. The interpolating point is a 4 by using quadratic Lagrange polynomial. And this is the last part, is to compute the absolute error. Now you remember that one here. The quadratic Lagrange polynomial need only 3 points. How many points we have here now? We have a 4 point, 1, 3, 5, and 6. So we need what? We need only 3, and 3 point must be, we have to choose. Remember, as I told you, how to choose 3 point. Should be close each other, smaller size of the interval, and interpolating point 4 must be موجود in it. Is any student give me an idea which 3 point you have to select and why?
3, 5, and 6.
You want to find 3, 5, and 6. and we choose this is the best point because 3 to 6, how many distance we have? 3. But if we choose 1, 3 and 5, 4 still modules in it, but here the distance is a 4. Smaller the size of the interval, better the approximation. It means the best approximation is 3, 5 and 6. So that's the table we need for our the quadratic case we have here, because he give you the idea, use quadratic polynomial. So you can have here now, you know what is the formula? This is a quadratic Lagrange formula. Only difference you can see, in place of f of x, I'm using m of alpha. Exactly the same thing we have here now. Now we know what is L naught. We have to compute. What is f of L naught? This is 1.28. I put the value here into L naught 4. What is L1? We have to find out. And what is f of alpha 1, which is a 5 here, which is 3.2817. And this is alpha of alpha 2 is a third point. This is this one. You have the value, and you can have, this is the approximation. The only things we have to calculate L0, L1, and L2. There, you're using the formula of L0, inshallah, you will get that one. Using the formula of L1 and all the information given, you are given alpha 1 is 3, alpha 2 is 4, 5, and alpha 3 is 6, and the interpolating point is 4. So you can all the value here, and then you can find out L2. And as I told you, before you use the value of L0, L1, and L2 here, you must be guaranteed that your value of L1 and L2, these are the sum of this L, should be always equal to 1. If it is not coming 1, it means something wrong with your calculation. What is your L0? 1 by 3 plus 1 minus 1 by 3. So 1 by 3 minus 1 by 3 cancels. Over left is a 1. Alhamdulillah, these values are correct. So put the value of L0 here, which is 1 by 3. So you have this. Put the value L14, which is 1 here. We put the value here. And you put the value of L2, which is minus 1 over 3. You put the value here, and inshallah, you will get the approximate value of the function at 4 by using quadratic polynomials 2.2817. Now, he said that compute the absolute error. And absolute error is what? Exact minus approximate. Approximation you just find. Can you give me an idea? What is your exact? What is your exact?
Substituting 4 in the equation.
Yes, the exact is m into 4. Because as I told you, in 254, we are always finding the approximation of exact. He said, find approximation of this one. So this is your exact. So what you do, you know the formula of m of alpha. In place of alpha, you just put 4. And inshallah, when you put the 4 here, this is when you put the 4, and that's the jawab you will get here. So this is the absolute error. And you can see the exact is and the approximation exactly same, but it is not nice to say exact and approximation are equal. We can say, yes, they are equal up to how many digits? Up to 4 digits, 4 decimal places. The 4 decimal places, the exact and approximation are exactly the same. It means, therefore, we have the error is 0 up to 4 decimal places. Right? So this is a good example place we have. No need to do example number 4.8. Now, that's it. Okay, let's say this is slightly, I make trick here now. How many value we are given? X is 4 point. And when teacher say, in the exam, when I say use the best Lagrange polynomial to find the missing term. Best mean you have to use all possible points given in the table. If teacher mention you linear, so it means you have to pick 2 points from the table. If it in the mention quadratic, you have to put 3 points in the table. If we say cubic means degree 3, you have to put 4 points. Degree 4, you have to pick the 5 points here, like this one. This is, how can you do this one? Which best polynomial you will use here, please? Any student?
Cubic.
Which one?
Cubic.
Let's I give you here. Your x value are what? X value are 0, 1, and 6. And the f of x value are 1, 2, and 3. And the question is what? He say find f of 2. Can you see how many points we have here now? 3. Can you check this problem and this problem is same or not?
It's the same.
Is exactly the same here. Because this is, we will not count 4 points, we will count only 3, 0, 1, and 6. Why? Because we have no value at 2. And that we have to find out. This is a way we do here. So it's mean how many points we have? Only 3 points here. It's the best polynomial we have to use here is what? Quadratic polynomial, which I use here. The best point are this one. And then we can find out the approximation at. So this is a formula we have. You know f of x naught is 1, f of x1 is 2, and f of x2 is a 3. So I can put the value here. You use the value of L naught, L1, and the formula. You must remember that one here. This is the things you can put the value there, and then he said find the missing term at 2, and then that is the interpolating point is 2. So that's the jawab you will get. Exactly the same thing, simple way, but slightly tricky way he give the table here. Because here is the missing term at 2. That means we have to find what is the approximation of the function at 2. We can find approximation of the function at 2 remaining point, which is our 0, 1, and 6 here. Let's take this example. This is also very good example. He said the equation, nonlinear equation, this is, has a root inside the interval. And he said compute the Lagrange polynomial for this point. How many points given here? 0, 0.5, and 1. How many points? 3 points. So it means which Lagrange polynomial we will use? Of course, we will use the quadratic polynomial, because quadratic polynomial needs 3 points. And then use it to find the approximate solution to the given equation. And that approximation must be inside the interval here. So it means you can have here what is your function is given here, not directly given. The function is given this one, because this is nonlinear equation, and the nonlinear equation, the left hand side always f of x and the right hand side always equal to the 0 we have here. Now x we already have. This is your x, 0, 0.5, and 1. And at 0, what is the jawab? You have 0 minus 9 power 0, which is 1. So we have a minus 1. The same way you can find the value of the function at 0.5 and this. So how many? Now you have the function table concerned. Now you are ready to use a quadratic polynomial, which is this one. And in this one, L naught, you have to find L1, you have to find L2, you have to find out f of x naught given minus 1, f of x1 given 1 over 6 and f of x2 is given 8 over 9. So I put here the value here. So we have this one. Now you calculate the value of L naught, which is this one. Then we calculate the value of this one. And we find the value of L2 here, this one. Put the value of L naught, which is this, L1, this and this. You can put, and after simplify, you have this expression. Now you can see here, what is f of x in the nonlinear equation? F of x in the nonlinear equation always equal to what? 0. And then you can have here now, you put f of x is equal to 0. It means p2x is equal to what? This one, which is equal to 0. And when you simplify this one, this is the expression you will get. And this is the quadratic equation. If you cannot make the tahleel of this one, the factor of this one, you can use a quadratic formula. And when you use a quadratic formula, you have a 2 root this one, which is this one. And we are interested which root, which must be inside the interval. The only one root is inside the interval, because this is not inside the interval. It means your jawab is what? Is x2, which is 0.41515. That's the jawab here. So this is very good example from examination point of view, because this is the application of the nonlinear equation with the help of quadratic Lagrange polynomial. This is second example I give you here. You remember, I don't, if you remember your, what you call it, the 106. In 106, you have many techniques. You have integration by parts, you have the trigonometric integral, trigonometric substitution. And one of the techniques, if you remember, is called partial fraction. And the partial fraction is what? When you have to use the partial fraction, when you are given a polynomial function. And polynomial function is what? Is the polynomial taqsim polynomial function. It's called the rational function. And the degree of the up or plus should be less than the degree of maqam. Then you can make the partial fraction, which you can do what? You make the tahleel of the denominator. Then you put a1 taqsim by first factor plus a2 taqsim by second factor, well, like this. And then you use the value of a1 and a2 like this one here. So when I give this one here in the exam, I say use quadratic polynomial, express the rational function, this one, as a sum of the partial fraction. But when I give in the problem this one in the exam, I say, what is this one? I say f of f taqsim gx is equal to what? A1 taqsim by the first factor, and the first factor is what? X plus 3, sorry. X plus 3 plus A2 taqsim by the second factor, and the second factor is what? X minus 0 or X, and the third is what? A3 taqsim by the third factor X minus the 3 we have. Now my question is, use quadratic polynomial to find the value of A1, A2, and A3. And when you find, this is called partial fraction. So what is we are given here? We are given this one. What is this? F. This is your F, right? And what is GX? We have this is a GX here. And we can make the tahleel of this one. The factor of this one are this one. And factor always use as a 0 of the maqam, 0 denominator. So X value are what? Minus 3, 0 and plus 3. So these are the X value you have here now. Then you have to create the table. x and f of x. What is your f of x? Your f of x is equal to what? This one. To find the value of f of x at -3, you put in the, not in the whole this one, only in the plus, because the plus is your f of x. And you have 36 and like this one. Now you have 3 points. You can easily use a quadratic polynomial. And the quadratic polynomial is what? This is the quadratic polynomial you have here now. You know f of x naught. What is f of x naught given? 36. F of x1 is a -9. F of x2 is f of x2 is what? Is a -18. You put the value here now. Only unknown are L0, L1, and L2. L0 you can find by this formula for L0 for every problem, and then you use the information. You can have, this is the shape. Then the same way you can find out L1 and L2, and you can have here this one. Now, just put the value here now. So what is your value when you put that one? 36 taqsim by L naught x, which is this one, and after simplify, you will get this one, the first term. Second term is what? The second term is this one after simplify, and the third term is this one here. This is, you make the factor of f of x in this form here. Put the value, this is f, this is g, and in place of x you have to put what? You have to put this one. So you have this plus maqam, this plus maqam, this plus maqam here. Make them separate, huh? And then cancel the term, and left, inshallah, you will get this one. And this is what? This is the partial fraction you have here. The value of a1 is what? 2. Value of a1, a2 is what? 1. And value of a2 is what? -1. So this is a fraction you have here now. So that's how can you use the quadratic Lagrange polynomial for approximation of the nonlinear equation. And now how can we make partial fraction of the given rational function with the help of the quadratic. You have any question, please, up to this point now? Is okay now? So we have how many? 11 examples is more than enough now here now. Lest we talk about now the important formula. How can we define error formula? You remember that one. Whenever we do numerical method, we have to discuss this error bound formula. So that's what we are discussing now. Error formula of the Lagrange polynomial. Now I give you the error formula for one thing before I give you this formula, please. You must be very careful. As I told you, if any problem come in exam to find approximation of the function, as I told you, by using the Lagrange polynomial, I told you already, in exam, teacher always give you either degree 1 or degree 2, not more than this one. He never give you find the approximation function at the given interpolating point by using cubic or what, because it's lengthy process. But when teacher asks you find the error, he can ask you the error of degree 1, 2, 3, 4, 5, 6, 7, 8, whatever the things here. So that's, there is a sequence of the error formula, and you understand, then you have no problem here. Now this is the error formula of degree linear 1. This is the error formula we have here now. And what is this one? It is second derivative at eta. What is eta? Any unknown point majud inside the interval taqsim by 2 factorial. And we know for degree 1 linear means degree 1. How many points we need? We need 2 points. That's what we have here, x0 and x1. So this is the formula. Now, if you use the higher now degree, you can increase the derivative order, you increase the factorial, and you increase the term. This is a simple way to memorize here now. For degree 2, how many points we need? For degree 2, we need the 3 points. And the formula is this one. Now you can see what I did. For degree 2 is second derivative. Now we have a third derivative. Here we have 2 factorial. Now we have a 3 factorial. And how many terms we have? 2. Now we have a 3 because we have a 3 point here. So this is a simple way here. And if we have a degree 3, what is degree 3? 4th derivative, 4 factorial, and we have one more term, x minus x3 here, like this one I give, I think. Yeah, this is I give here for the degree 3. If that he said degree 4 will be what? 5 point. So you have 5th derivative, 5th factorial, and you have one extra term here, x minus x3. This is way you have to do. Now I give you, continue in this manner. We can have degree 4, 5, 6, and I give you the general formula for degree n, which is this one here. So for degree n, we have n plus 1 derivative. For the degree 3, derivative order must be 1, 4. 1 bigger, which is 4. For degree 2, what is the derivative order? This is 3. So for degree n, we have n plus 1, x minus x, and up to x minus n. So this is the error formula we have here now. But we need the error bound formula, and error bound formula always we need the maximum value of this derivative at the given interval. This is the only things for finding the error bound. Error bound we take absolute on, which I discuss inshallah later on here. Now we can have here now what? Let's take the simple example I give many time in the exam also. I say let f of x is equal to x minus x square and p2 be the quadratic Lagrange polynomial on x naught 0, x1 is alpha, x2 is 1. So we know 0, we know 1, but what we don't know alpha. And the question is what? Find the largest value of alpha inside the interval with the condition that f of 0.5 minus p2.5 must be equal to minus 0.25. So we will find the value of alpha. So alpha, maybe we have a 2 value or 3 value, maybe 4, maybe, but we have to choose only the largest value, which must be inside the open interval, not closed interval. So if you have a problem, no, the question you not understand, but you understand this one. How can you find f 0.5? Very simple. You put x is equal to 0.5 here, and you can get this value. Minus P2, you know what is the P2 formula. This is the P2 formula. And you can easily find out P2 formula, quadratic polynomial. We need how many points? We need 3 points, and 3 points given by the teacher. 1 is unknown, which we are going to find out here. What is f of 0? Put the f of 0. You put 0 here. So 0 minus 0 square, sorry, is give you the 0. And f of alpha is what? Only replace x by alpha. So we have, what is f of 1? F of 1 is 0, because 1 minus 1 square is a 1, so 0 here. So what is your formula? This one. So but this formula become the shortcut now here. Is this one now, after putting the value here. And we know f of x naught is a 0. F of x2 also 0. So no need to calculate L naught, because if you calculate, some student calculate in the exam value of L naught and L2. No need, because when you calculate the value of L naught, you are multiplying by what? You're multiplying by the 0. So it's mean only we have to calculate L1. This is the L1 formula we have here now. We know x minus 0 and x minus, because for L naught we never use x1 up. x1 is what? Is alpha. We use in the denominator. So x minus 0, x minus 1, alpha minus 0, alpha minus 1. And when you do this is L0, you can simplify here. You have this value. This is L0. Put this L0 in place of this one here. And when you put here, you have your quadratic polynomial, this shape. And now in place of x, what you have given 0.5, find the value of 0.5, which inshallah you will get this one. Now you have to find out what? F of 0.5 you can have given with this one. This I can write here, this form, exactly the same meaning, please. Is what? Because I just took there, I took P2 negative on the other side, and this one I take here. So we have f of naught. F of 0.5, when you put in the formula, in place of x, you put 0.5 minus 0.25. Inshallah, you will get, this is the value of about 0.5, and this is 2 here. So this is equal to 0.75. So what is the question? We have now P2 0.5 is equal to 0.75. And what is P2.5 is this one. So just equate with this one here. This is the things you have here now. Now you play with it, and after simplify, you have this one. And then you take the square on both sides. So when you take the square side, what we left? Square root with vacancy, so we have this. And when you take the square of this one, you have this. And when you simplify, you have this one. So how many roots this one have? The 4 root. One is 0, other is 1, another we will find out here. 0, can we take 0? No, 0 is not majud in the open interval. Can we take 1? No, we cannot take 1. Also, this is not majud in the open interval on, because he not give you the closed interval. He give you what? The open interval. And that means we have here now, it's mean what we left? Solving this quadratic equation. You make tahleel of this one, or you make quadratic formula, and this will give you this 2 value, and both value are coming inside the interval 0 and 1. But teacher say, give me the largest value, and the largest value is what? 0.8. So this is the jawab we have. So very good question, please, from examination. The point we have here now. Have any question for this case, please?
Clear.
Okay. And this is also very, very good example. Many times I give in the exam this example here. He say f of x is equal to 1 over x. Define in the interval 2 and 4. X0 is equal to 2, x1 is equal to 2.5, x2 equal to 4. How many points we have? It's 3 points. Then he say, use the value of unknown, compute the unknown point eta in the error formula of the quadratic Lagrange polynomial for the approximation of f3. You remember I give you the error formula of the quadratic Lagrange polynomial is what? Is this one. Right? We have to, and this point, what we know? We know x, we know x0, we know x1, we know x2, we know 3 factorial. But what we don't know, the eta. Eta is unknown point majud inside the interval, and that the teachers say, use this error formula of the quadratic polynomial, compute or find the value of eta. So it's mean first things you have to calculate what? What is your x given? 3. So x0 given, x1 given, x2. So first you have to find f of 3. Function given, you can easily find. Then you use quadratic polynomial to find P23, this jawab left hand side. Right hand side, you put the value 3 minus x0, 3 minus x1, 3 minus x2, taxim by 3 factorial, you have the jawab. But you have to calculate the third derivative at eta, and then you can compute. Let's I give you here the how can I work for this case. This is a quadratic polynomial. You know that one. This is a point given by the teacher. It means you have to find f of x naught, which is f of 2. And you can easily find f of 2 is what? 1 by 2, because your function is what? 1 by x. What is f of 2? 1 over 2. What is f of 2.5? 1 over 2.5. What is f of 4? 1 over 4. That's the value I give here now. Having the value this one, now you can easily find out here the f of x naught half, L naught 3, f of x1 1.25, L1 3, and no, sorry, please, this should be what? Here the mistake here, it should be 4, please. I make here correct here, please, but here I didn't change. I will change inshallah. This should be the 4 we have here now, because f of 4 is 1 by 4 here. Now you have to calculate L naught, L1 and L2, and you have here, before you use, you can check please, L naught plus L1 plus L2 should be equal to 1. If it is not, check again, but inshallah it will come 1 here. So you put the value here, and you have the approximation of P2. And now you can easily find out the left hand side, which is F3 and P2. What is f of 3 exact? And what is f of 3? 1 over 3. We have this one. What is P2 3? You just find this one. And this is your the right hand side here. So we have the value of this one, which is this. Now what we need now, please, we need this one. This is 3 minus 2, 3 minus 2.5, 3 minus 4. And when you do this one, inshallah, you will get this one. 3 minus 2, 3 minus 4. Taqsim by 3 factorial is what? The 6, right? And now what you need? The third derivative. You know the function is given 1 over x. What is the first derivative of 1 over x? Derivative of 1 over x is minus 1 over x square. And in place of x, we have a eta. And then you can find out the second derivative, and you can find out the third derivative, inshallah, you will get here. And this is your right hand side. And when you 6 cancel, and when you simplify this one, inshallah, you will have this one. So what you have here now, left hand side, you have 0.0083, and the right hand side, after calculating using the error formula, you have 0.5 taqsim by eta 4. Now you have to play with eta 4, you take on the left hand side, and this will come in the denominator. And when you find, you will get this is eta 4. But we need eta. You take the square root on both sides, you have the value of eta square, and take one more time square root, we have eta, and this is the unknown, and the condition for unknown eta is must be inside the interval. What is your interval? Your interval is from 2 to the 4. So this is a very good example, please, from examination point of view. If teacher say find unknown point eta, it means always we have to use the error formula of the Lagrange polynomial. If you can see here, the error formula I give you here, this one. This is simple error formula. This is a simple error formula for what? The linear Lagrange polynomial. This is error formula of the quadratic, this is for the cubic, and then you can find degree 4, 5, 6, whatever here. Now, we need error bond formula. So please, the error bond formula for degree 1 is what? Error bond formula always in the absolute sense. And what is this one? This is always less and equal to, this is the things we have here now. And we take M. I will tell you what do you mean by M. M into absolute of what? X minus X naught, X minus X1, right? This is absolute. And this is whole taqseem by what? 2 factorial. And then you can put here, you can write this one in this simple notation. This taqseem by 2 factorial. You know X, you know X naught, you X naught and X1. The only things you don't know is M. That you have to find when teachers say error bond formula. So what is M, please? This is remember that one. What is M? M is the maximum value of the second derivative in the interval. In the interval X naught to X. So what you do, how to find M? You take the second derivative of the function and then find the second derivative of the function at X naught and then at X1 and then choose the maximum value. That is the value of M. This is called the error bond only here. For error bond of what you call degree 2. Can any student give me please? What is the error bond for degree 2? For degree 2, this should be what? E2. This is the error bond we are looking for. And it is what? Less than equal to M. And what is the point? 3 points we have? We have X minus X2. Agree? Taqseem by 3 factorial, and 3 factorial is what? 6. And what is M? M is the third derivative of the function inside the interval. What is your interval? Your interval is X1, X0 to, this is the things. And this is the way you can find the error bond formula for degree 3, degree 4, degree 5. And the only things you have to find M. This is because we don't know eta. Therefore, we take the maximum value of the derivative of the function at the given point here. Next time, I will give you the example of that one. Any question you have, please, up to now? Any student, any question? We have how many? 30 students. Any question from anyone? Always no. No question. Because they are just sitting, wallah, by force, only waiting for the attendance. Okay, I will take the attendance now. We continue, inshallah, more about that one next time here. Let's stop the recording.